Now we're going to look at some of this AI in the edge and more, I think, Eric, right? So there you go. Look at your.
All right.
There you go.
All right. So I'm Eric Wulfsberg. I'm a Senior Director of Product Line Management at Radisys. Radisys is quite active in supporting both mobility applications, as well as fiber to the home, broadband access, as well as kind of 5G core aspects as well. So we kind of touch on a lot of different access technologies here. So we got a little different perspective across different AI use cases. We're also a media engine for some of the conference call systems and some of the tools that various operators can use in their network. So we all know, of course, generative AI, all the applications that people use today in terms of our large language models, everything on the CB connection and services that they use. Really the discussion today is about how they're going to actually receive all these things. How is the network going to be modeled? What are some of the tools that are going to be used from a planning side in terms of the resource utilization, management, automation. A lot of the kind of functional areas that will be touched on in terms of what Phil and Shrisha had presented. And many of the different data sources, of course. There's the in-network data, the private cloud, there's hardware-based decision-making processes, and of course, public cloud, different data sources, which again, AI is very good at stitching together to give analysis. So this is all kind of the drivers toward these kind of futuristic and autonomous networks. So a lot of it, of course, it has to be business case driven. And what, from an operator perspective, and I think from a CapEx perspective, is really kind of a lot of those internal tools. I call it B2B, but it's really within the operations realm of the company itself. So what are some of the tools that customer service reps can be using? What the finance teams are using? The planning, the analytics, the depreciation of equipment. So you're looking at the network design, of course, AI in terms of where is the propensity to buy, where is the network being built out. You start to add in geolocation information as well. You can really incorporate some of these into this decision-making process. Of course, assets and network inventory. What is the capacity usage in certain areas? And really, again, contribute to a lot of that CapEx spend. And so is there a business case around this? Well, it's really around what are the tools that are being used within the operations side. And then predictive maintenance. I think Phil mentioned that as well. As you're looking at the assets that you have, what is the utilization? What is is there a failure mode that is being repeatedly seen? When do we schedule that maintenance activity? On the OpEx side, of course, some of these tools can be on the B2C side. These are actually maybe tools that are actually exposed to the consumer itself. You may have, again, enhancements for the consumer services side. We have language translation. Ourselves, we're very active in the international market. So you've got global country based with multiple languages. So you could do that voice translation within the customer care package. You got sales and marketing opportunities, all using opportunities to use AI. So again, optimization of the network, autonomy. You've got analytics that are helping in some of the decision-making support. And again, what I think is kind of interesting to us is sustainability. So if you're looking at how, it's not always just about latency. How are you using your switch capacity? How are you using your pathways, latency, and it's also about how those resources are being used and routing resources into underutilized equipment to actually kind of optimize your network as well. So the business rationale is any carrier. Obviously it's all services, it's low latency, it's capacity, reliability, connectivity. But the hows, in terms of all that telemetry, all that data is available. And I'm really going to address most of the kind of the CPE side, what's really evolved here in the last 15 years. The creation of these AI workflows, of course, these are model-driven operations. You may have intervention with a human, but you start to learn and you start to let some of the decisions being automated. Of course, you also have session steering. You can be able to route traffic to the most optimal ways of doing so. Again, many of these are kind of driven by some of the broadband forum standards. We're very active in the cloud CO and software-defined networks to segregated solutions. So really the definitions of how you steer traffic, how you support multiple ISPs, help in that automation of different networks, all part of the basically planning of the network here. And again, the net effect is, we're trying to reduce complexity. If you're looking at the wireless space, disaggregated solutions with the separation of the RU from the DU, the number of profiles, thousands of different profiles, it's an incredibly complex equation to try to optimize the network. And you can't just all manually code all these changes. Of course, increase automation. And then the end goal is simplicity. In terms of that decision support tools, how the reporting, the daily reports, the assessments of your network, how can you simplify and make things easier? So many different layers and many different inflection points of the use of AI, of course. And I'm really focused, my personal is on the bottom side, on broadband access, again, active in fixed wireless access, in 5G, as well as fiber to the home, and much of the device level. And again, this evolution of tier 369, tier 69, all that data available, plus other data sources at the edge. I call it the intelligent edge. There's more and more and more data. There's more knowing of what's actually the topology that's inside the home, what is actually going on inside the house, and then trying to correlate that to the actual operation of the network. You can have silicon-based decision-making processes. These may be on the OLT itself, trying to optimize service flows based on packet inspection and prioritizing traffic. That may be a silicon-based optimization. As you kind of move up, of course, you got management systems, you got all the data aggregation, and these may be cross-linked to each other, enhancing their data across different management platforms. On the aggregation side, I'm showing a kind of a spine leaf architecture. If you're looking at cloud, CO, very large systems, you may have a very large switch matrix. You got the routing at the spine. You got layer 2 switching at the leafs. This could, the same topology can be seen in the wireless space as well. Again, I mentioned these, the front haul capacity of an RU and DU. You have multiple pathways. So it's not all just latency. It's utilization of the equipment and optimizing the path. You get up to a higher level, of course, you got real-time data analysis. Again, you're marrying all these different data sources together. You're creating digital twins, try to emulate and simulate what's going to be happening in your network if you're making some changes. Different AI workflows, what databases are being touched and being processed during that form. Of course, just all that data, the telemetry being recorded. And I kind of say that, intent-based networking, machine optimization, many of these things are working across different domains of the system as such. And then at the highest level, maybe layer 7 or maybe it's a layer 8 with a human involved. You have the operation side, OSS, BSX functionality, the customer experience, KPIs, how to optimize the home network. Of course, these may be tools for the sales, the marketing, BI tools. So at that edge, again, this is kind of in my realm here, the evolution of tier 369, the amount of data available with IoT, of course, with MQTT, you've got speed tests, you've got other agents. You may have security applications. You may put another agent on to the device. Here you'll be able to get kind of a more detail as to the service flows, what the actual clients are within the home, revision model of the device. Content, you're looking at the applications, you look at the services, real-time data collection, and using that data within some of these AI models. And we're also active in open Wi-Fi. So if you're looking at kind of public Wi-Fi, open Wi-Fi initiatives, OpenWRT-based types of systems, again, you could hold different agents, different data collection. You're seeing public usage of the Wi-Fi in a different way. Now, these can be, with ACSs, with security clouds, or Wi-Fi controllers. These can be interlinked, obviously enriching the data within themselves, security applications, knowledge that can be interlinked. But of course, as they go up to an aggregation system, here you're able to see, again, correlations. You're pulling a lot of data and analyzing it. Now, this doesn't have to be standards-based, but we're in a broadband forum session, so we are standards-based, but there may be other proprietary solutions. You maybe have a Plume solution. You may have another WebSocket solution. There's lots of different agents out there. And again, the value of AI is be able to stitch dissimilar data together without really, basically kind of marrying that data together across different data collection. I mean, the physics doesn't change. Wireless is wireless, connectivity is connectivity, but the data collection, what that means into the database may be different, and AI can help resolve that. So again, if you have different agents on there, different clients, maybe an Arrow could be a TP link. They have different ways of actually instantiating some of the Wi-Fi management and kind of related functions. So that value in the edge intelligence or intelligence of the edge, you may have kind of just straightforward binning. You may be just grabbing historical data. You may have an ACS that's actually putting together multiple functions of the device, hardware performance, optical performance, the wireless 5G performance relative to the actual performance, the home user, the QoE. Of course, in the network topology, you may have an embedded speed test, tier 143 from the broadband forum. You may have an UCLA. You may have other types of speed tests. Able to do that speed test, but know that there may be crosstalk, maybe other data services running at that time. So repeating that data and knowing and filtering out some of that crosstalk information. Again, the end all is these pretty large data lakes. And this has really only evolved in the last 15 years. This availability of all this knowledge within the home itself. On the kind of the security side, again, details on the CP, very detailed fingerprinting of what actually the agents or the clients inside the home, identifying based, exposing what is actually running the house, so you can discover vulnerabilities. Again, are these devices protected? IoT devices that may have very limited security features, are able to kind of provide additional protection for those. It's really the aggregation of a lot of these systems here. You're learning the service flows, the application flows. You're really getting a large amount of data of actually what is occurring in real time. And then protecting the network in terms of DOS attacks or other vulnerabilities to those equipment. So again, just a huge amount of data at the edge, how that all can feed into some of these AI engines. But of course, as we see, there's risk rewards. There's got to be a business case. So as you expand the different layers of complexity, there's a lot of risks. At the very top, maybe there's efficiency tools, decision-making reports, customer service tools. Again, things to help make recommendations, moderating, trying to do discovery of what's impacting the customer's use case in the house. You get into more complex, of course, network planning. You may have conditional approvals, the human in the middle to help kind of moderate some of these AI workflows. Again, these may be, again, recommendations for operations, planning purposes, how are my assets and capital being utilized? And then you get into really autonomous networks. And here you have to have, you have many different access technologies, different platforms, different vendor platforms, trying to do these cross-domain applications, traffic steering across multiple domains, reuse of capacity into different areas. Again, it's not all just about jitter and latency. What can you do in terms of closed loop operation? What are you doing to kind of protect your network over time? So very complex, and the migration will take time. And again, the question is, will it really ever be autonomous, or will there be a human in the middle? But one of the things that kind of interesting to me is that because of AI, you have the ability to pull in other data. And I'm just using ArcGIS, and a lot of people have Esri ArcGIS in their systems today, or other GIS platforms, location-based. And you can use that data to obviously enhance your planning side, your asset tracking. You have so much data available to you, but it's not really something you can use on a day-to-day basis, but AI can help use in the planning side. Again, very location-based and asset-based. So, government databases, there's social economic information. Here's the areas propensity to buy, overlay with your network build-out, your tower sites, if you're doing wireless access. There's so much data information. Of course, active data, there's utilization of the network. There may be, as Phil mentioned, weather. We've just had a pretty enormous solar storms, if anybody saw the Northern Lights. But, it was actually in Minneapolis. But these are all, I guess actually working in a weather company, and there's resources out there for tornado tracking, for weather patterns. How are your resources being used to effectively roll out your network? And then you can also enhance that data, satellite imagery, user data. There was a case study that Geo participated in with Esri, just about the massive amounts of processing that they have done to plan out the network. And so it's a very interesting case study. Again, this information is available and applies into the network planning side. So just kind of bring this close. There's a lot of challenges. I'll call them the hurdles and such of rolling out AI. We've kind of touched on these during the conversations. One risk is obsolescence. The AI models, the training. This is a huge data science project, and so things are changing very rapidly. So as you look at different AI models, they may resolve to different conclusions here. There's regulatory requirements, GPRD, your privacy, having in-network versus out-of-network. Can you train these models? Are you large enough, like maybe a Vodafone, to train your models on internal data without any external resources? You got the issue of trust, of course. The models, are we resolving to the right conclusion? So the validation over time. Is the data ready to be ingested by these AI models? The format of the data, the correct, be able to process that data. One aspect is just resource. For a small operator, you may not have, the time, the expense. How are you going to kind of manage this? Who is the data scientist? So there may be canned products. There may be, again, an ACS with a recommendation engine, something to help on troubleshooting tools. Different products that you may purchase to help augment your network rollout. Of course, with anything, then it's just the cost. Is there a valid business case, return on investment? How I'm going to incorporate these tools? Do I see a return quickly? And again, just as we kind of leave you with this, there are many different forms looking at AI. Obviously, the different interfaces are available. Within the kind of the 3GPP world, there's a interface called consumers that may be both the apps, the services, the B2C type applications, as well, again, third-party databases such as ArcGIS to feed into these AI models. We mentioned the TM Forum, and again, the Orion Alliance is really looking at the complexity of networks to kind of optimize the actual usage of the radio heads. So with that.
Excellent. Well, thank you, Eric. And